Hey everyone, welcome back to part 2 here, and we're going to talk about security models. And security models are just a way for us to really understand how to develop security into a system. And it's a way of providing guidance around, a model is used as guidance for people, processes, and technology to be able to implement security. And when we talk about people, we're talking about the workers in a organization that are there to implement a given system. The processes are the rules and the guidance that the people use in order to implement that system. And then the technology is there to support the people and the processes in order to implement that system. So addressing a single one of these, whether you're just leveraging people or whether you're just leveraging technology, is not going to be sufficient in order to get to where you need to be. And so therefore, the three of these together are really the best way to implement something like a security model. So when we're looking at a security model and how it works in the real world, the security model is going to be based off of or derived from an overall policy. And that could be NIST or ISO or so forth. And then you're going to use the security model to really provide the framework around how that system is going to act using that model. And you may use a programming language to implement, or you might use a specific technology to implement that model. And then in the end, you're going to have a product. And in this case, you might have an operating system or an app, or you'll have an operating system that comes out of that. So first, going to talk about trusted computing. So with trusted computing base, this is really creating a trusted security base using hardware, software, and security controls to enforce security policy. Security perimeter separates that trusted computing base with a boundary that ensures that there is no insecure communication or interactions. And secure communications can only occur over a trusted path. And in order to get access into that security perimeter, you may be able to use something like a trusted shell. A reference monitor will validate every access request to the object. Remember the terms object and subject, but the object is going to be some resource. So the reference monitor is going to access or validate every access request to that object before granting access to the subject. And so the collection of functions that implement the reference monitor are often called the security kernel. State machine model is based on the finite state machine. And what that means is that there's a state. And when the system is acted upon, the state may change, but may go back to its initial state after it's done. And this is a system that is always in a secure state, this state machine model. All transactions in a state need to be validated before proceeding to the new state. Information flow model is designed to prevent insecure information flow between two different levels. So when we're talking about levels, we're talking about the classification levels. Non-interference model will restrict how subjects at a higher level interact with lower level subjects so as not to create a covert channel. So access control models, we have ACL. These are access control lists. Some of you may be familiar with this. This is the way that permissions are attached to a given object so that those that are trying to access that object have a list of ways or permissions that are assigned to that object. And the only way to have access to that is to ensure that you are part of the permission set in order to have access. Bell-LaPadula model. This is a model that is a formal state transition model of computer security policy. And basically it describes a set of access control rules which use security labels on objects and clearance for subjects. Role-based access control, or RBAC, not to be confused with rule-based, another type of RBAC, is a policy-neutral access control mechanism defined around roles and privileges. So your role, if you're an admin, you have certain privileges. If you are a standard user, you have another set of privileges. Access-based access control, also known as policy-based access control, defines access control whereby access rights are granted to users through the use of policies which combine attributes together. So this basically says if you're located in a given geographic location at a certain time, you might have access or you might not, depending on how the access-based access control model is constructed. The take-grant model. This determines how rights should be passed from subject to subject or subject to object. A subject with a grant right can grant the right to another subject or an object. A subject with a take right can take that right to another subject or object. 4 rules of take grant. So there's a take rule, a grant rule, create rule, and remove rule. The take rule allows a subject to take rights over an object. Grant rule allows a subject to grant rights over an object. A create rule allows a subject to create new rights. A remove rule allows a subject to remove new rights. So what about the multi-level security model or an integrity model? There's BIBA, integrity model, and this is designed so that the subjects may not corrupt data in a level ranked higher than the subject, or be corrupted by data from a lower level than the subject. And this is often a good way to describe this is a monk may write a prayer book that can be read by commoners, but not one to be read by high priests. And so, in other words, the monk can't write something that could change the integrity of the high priest, but they can write something that can be read by commoners. The Clark-Wilson model, instead of defining a formal state machine, this model defines each data item and allows modification through only a small set of programs. So basically, access is only allowed through a small set of programs. The Brewer-Nash model, or the Chinese wall, means that technology can be employed to prevent access to data by conflicting groups. And so you don't want to cloud another group's judgment or therefore change the integrity of another group by allowing them to have access to information from a partner group, even in the same organization. And with that, that's security models, and I appreciate your time, and I look forward to speaking to you again. Thank you.